What's up, everyone? This is LeetCode 101, Symmetric Tree. So we're given the root of a binary tree and we have to check whether it's a mirror of itself, i.e. symmetric around its center. So when we're saying, right, a tree is symmetric, we're not saying that the subtrees are the same. We're saying that they're symmetric. So imagine we have a mirror. When we look at this, when we point that mirror towards this tree here, right, when it's reflected, right, this 2 should be here and this 4 should be here, right? Right? That's what we mean by symmetric. Okay, so this tree, for example, would be symmetric, so we return true. Now here, for example, if we had a mirror right down the center, and we reflect the mirror on this subtree here, this 3 should be here on the left, to the left of this 2. But you see how this 2, for this tree here, this 2 is actually, it doesn't have the 3 here, it has it here. So this tree is not symmetric, right? Around the not symmetric around its center, okay? So you'd return false, okay? Okay, so I want to show you this just to show you how we would check if a tree is symmetric, right? How kind of our algorithm is going to work. So we're going to go left, right? And we're going to go right. Okay, we see that this node and this node are equal, right? They both have the value 2, right? That's great. Okay, now when we go left here, we have to go right here, right? Notice this is a 3 and this is a 3, okay? When we go right here, we want to go left here. This is a 4 and this is a 4, okay? So that's how we check if a tree is symmetric, right? When we're on the left subtree, every time we go left, on the right subtree, we actually want to go right, okay? Because again, think about, how we would mirror these subtrees around the center, right? When we go left, we go right. When we go left here, we go right here, okay? So in terms of what would break our algorithm of checking whether these trees are symmetric, it's really two things, right? If we're at this 3 and we go left, and there's a node, let's call it 5, if we go right on this subtree, right, we should expect this to be a 5, but what if instead we have null, right? That would be a case where we would return false, right? Where it wouldn't be symmetric, right? Because if we're at this 3 and we go left and we see a 5, when we go right here, we expect to see a 5. Or, for example, if we're at this 3 and we go right and we see a null, when we go left here, we expect to see a null, but we don't, right? We see a 5. So that would break our tree symmetry. Why? Because structurally, the tree is not symmetric, right? So let me write that. What would break our tree? Handwriting, well, let me just write it out. Thing that would break our tree. Okay. Let me increase the font here. So we already talked about things that would break our tree is when our subtrees are not structurally, I don't want to say identical, but structurally symmetric, right? Because when we go left from this 3 and we have a node, which is 5, when we go 3 and when we're at this 3 and we go right, we expect to see a node, right? That is 5, okay? So every time we go left and we see a node, when we go right here, we better see a node. Otherwise, we're not structurally symmetric. Now, we also could have another case that could break our tree, which would be, what if we do have a node here, but it's a 7, right? Well, when we go left here, we see a node, great. When we go right here, we see a node, that's great. But if their values are different, then these trees are not symmetric because the values are different, right? They both have nodes, but they're not the same nodes, okay? So that's another thing that would break our tree symmetry is our subtrees are structurally symmetric, but the nodes are not. I don't know how you would describe this. Value symmetric. Okay. So that's the two things really that would break our tree symmetry when we're kind of checking whether this tree is symmetric or not, okay? Now let's go back to the code. Okay, so we're gonna say, right, well, first of all, we have to define a DFS function, right? We're given a left and a right subtree, okay? So down here, we're gonna return DFS. We're given the root node, right, which is the head node, or kind of, we're given the root node of the entire tree. So we're gonna say root.left, root.right, okay? If not left and not right, return true, right? Now, if we have one node, for example, we're just given the root node is the only node. When we call this function, we're not going to have a left subtree, we're not going to have a right subtree, so we'd return true, okay? Which is what we expect, because we expect this tree to be symmetric in that case, okay? Now, if we have a case where one node exists, but one node doesn't, that would be a problem, right? So we return false. Because if we're at this 3 and we go left, and we're at this 3 and we go right, we would enter this, right? Because they both don't have child nodes. But if we're at this 3 and we go left, but we're at this 3 and we go right, if one of these has a node, which would be where we would enter this, right? Because if they both don't have child nodes, we would just enter this statement. So the only time we would enter this statement is when one of these doesn't have a child node, but the other one does, right? Right? Because if they both don't have child nodes, we would just enter here. So we're only entering this when one of these, when we go left here or we go right here. If one of these has a child node but the other doesn't, that would be a problem, right? Because structurally, the tree would not be symmetric at that point. So we'd return false, okay? Now, in terms of how we would check the values, we're just going to say this, okay? When we're at a specific point like this too, every time we go left here, we want to go right here, okay? So we're going to say root.left, or sorry, not root.left, I want to say left.left, right.right, right? Because when we go left here, we want to go right here. Likewise, we want to do left.left, right.right. Sorry, I don't know why I was writing it all in here, right? We need to call this function again. We're going to say left.right, right.left, right? When we're at this 2, when we go left here, when we're at this right, we want to go right. Likewise, when we're at this left, when we go right here, we want to, at this right, we want to go left. That's why we do left.right, right.left, okay? Because again, we're not checking if these trees are the same, we're checking if they're symmetric. So when we go left on one tree, we want to go right on the other. When we go right on one tree, we want to go left on the other, okay? But there's one very important part we're missing, which is what? It's checking to make sure the values are the same, okay? Just like that. So we're using this to traverse the tree. And as we traverse, we're checking to make sure that it's value symmetric, right? When we go left here and we go right here, we want to make sure these are the same value, and we also want to make sure that both of these nodes exist, right? If they both don't exist, that's fine, right? But if one of them exists and the other doesn't, we're not structurally symmetric. Likewise, if they both exist, that's okay, but there's a caveat. They need to have the same values, okay? So if they both don't exist, that's fine. Don't have to worry about it. But if we go left and we go right and they both have nodes, that's fine as well, but they have to have the same values. But if we go left and one of these nodes exists, but the other one doesn't exist, that's where we have a big problem, okay? So here is where we're checking. They have to be structurally symmetric. And here we're using this to traverse a tree. But here, every time we traverse a tree, we're making sure that the values are the same for the nodes that we're comparing, okay? And yeah, that's how the code works. Anyway, sorry if this video is a little bit long and I'm explaining a lot, but whoops. Def? No, I want to say DFS. My bad. Anyway, sorry if I'm explaining a lot, but I just want to make sure you understand kind of what conditions we're checking, right? We need to make sure this tree is structurally symmetric, but also that it's value symmetric, right? When we go left for a particular subtree and we go right for the other subtree, we want to make sure that the values are also the same, okay? So anyways, I hope this helped, and I'll see you in the next one.